Okay, let us solve the following questions. Given that R, which is the set of real numbers here, the set of real numbers is the universal set. So they're telling us that our universal set is just R. And they're saying that A is given by this, which is from -4 to 7. Though -4 is not part of the set. And we have B is from 4 to infinity. Of course, positive infinity is not going to be part of that set. And we have to find A complement, B complement, um, A minus B. This is a difference of A and B. It's a difference of B and A, like that. So how do we find this? Well, we can find this using the number line. That is, I drew my line here, and I'll just plot A first. So A, that is -4, like that, to 7. And of course, they're telling us the universal set is the set of real numbers from negative infinity, that's to positive infinity. So now, my A, it is open here, and it goes all the way to 7, and it's closed at 7. So when I'm looking at the complement of A, it's going to be closed here, since if 4 is not in A, it has to be in its complement. So all the way to the negative side, and here it's going to be open and all the way like that. So in short, a complement is just going to be negative infinity, open there, to -4, and it's going to be closed, union, because I'm joining these two parts. At 7, it's going to be open and all the way to what? Infinity, like that. So this is my A complement. Now let us do the part B, which is part 2, which is B complement. So, okay, I raise this part here. Okay, let me raise these numbers. Then, so what do we have? Okay, let me also raise this here. So what we have for this one is B. So B is given this way. That is 4. So if I say 4 is here, all the way to positive infinity, so it's going to be closed here, going that way. So this is my set B. So what is the complement? Everything, the complement is everything that is not in that set but sits in the universal set. So that is going to be open here, going to this side is what is not what is not in set B. So it will be in the complement. So B complement, therefore, is going to be negative infinity to 4, and it's going to be open there. So this is my B complement. So now I find the next one, which is A minus B. This could be written also as A intersect B complement. Well, I'll keep this complement here because I have seen it there, and I will just plot my A again. So let me plot my A again. So my A, okay, so my A is going from -4. So let me extend this here, and let's say our -4 is here. So it's going from -4 to 7, and let's say, okay, our 7 is here. So this is going to be, so which means we can also extend, okay, let me write this complement. So we could extend this like this. So it's open there like that. So this is my B complement. I've already plotted my B complement there. Then let us plot now A again. So A, it's open at -4, and it goes all the way up to 7, and it's closed at 7. Then where do these two intersect? So if I look at the intersection, that is this part here, this part there, this is where they intersect. These terms here are what are common. But then the endpoints, -4 is not in -4 is not in A, so it can't be in the intersection. And also 4 is not in B complement, so it can't be in the intersection. Therefore, A intersect B complement, which is the same as A minus B, or A, let's say difference of A and B is just going to be equal to, that is open at -4, since it's not part of the set. Then also it's going to be open at 4, So this here is my A intersect B complement. Okay, so how do I then come to the next one? Okay, so then the next one is saying set difference of B and A. So the set difference of B and A, which could also just be written as B intersection A complement. So let's see how this looks on the number line. So I erase this here. Okay, so we have our line here. Then B, we want B and what? And A complement. So I plot B. So B is going from, so B is 4. So it's closed at 4 all the way to positive infinity. So it goes all the way like that. This is my B. Then my A complement as found earlier, that is, we have this here, -4 and 7, but everything outside here is the complement. So it's going to be, it's closed here and going that way. It is, that's the first part, and the other part is open here and going that way. Then they're telling me where do these two intersect. So if I look at the intersection, it's here and this part here. So at 7 itself, 7 is not in my set. 7 is not in A complement, so it can't be in the intersection. Therefore, we're going to have that B intersect A complement, or set difference of B, or set difference of B and A is just going to be equal to, so this part here, that is open at 7 and then goes all the way to what? To infinity. So this is how I find that one. Okay, so let's do the next question. So the next one is saying let A, so she's saying A be that, be the universal set. So A is our universal set, and it's running from -9 to 9, where -9 and 9 are not part of the are not part of that set itself because they are open on both ends. And we have x there, which is from -1 to 5, closed at 5. Then y closed on both sides, -5 and 3, and z there. They're saying find each of the sets and display it on a number line. So they're telling us to find x complement. So how do we do that? So we have x there, so we'll plot x and then we'll plot the complement. So first, let's plot the universal set, which is from -9. So it's going to be open here at -9 and also open at 9. Then we plot the set x. Set x, I'll say if my 1 is here and then my 5 is there, like that. So it is open here and it is closed there. So this is my what? This is my my set X. So now to find the complement, everything that is not in this set but is in the universal set. So it's going to be here closed and then going all the way to -9, but to be open at -9, because -9 is not actually in the universal set. Then here it will be open, and also going there, it's going to be open. So this is my set X. So this is my X complement. I mean, the one in blue is my X complement. Therefore, X complement is just from -9 to -1, closed union, then at 5 all the way to what? To 9. So this here is my X complement. I can plot that also separately. That is, if I say this is universal set, of course, 9, -9 to 9, then plotting that, I'll have to just have -9 all the way to 1 and it's closed, to -1. Then at 5 here it's open, to there open. So this is my x complement. Okay, let's do the next one. Okay, so the next one is a and x. So let me erase this and leave the x there. So the next one is saying set difference of a and x. So x is from -1 to 5, while the a, which is the universal set, is from, okay, it is open. So it is open at -9 and also to 9. This is the a, and this here is x. So the set difference here is I am removing, or I am considering a intersect x complement, a intersect x complement. Well, or considering this directly, what you're just saying is that you're removing set x from a. So now when you look at where x is here, and we are removing this set x from a, and what do we remain with? So what we remain with is x complement. So the complement then is it will be this part here going that side, open there, and open here, and going where? Going that side. So this is what you remain with, and this here is our answer, and our answer is just from -1 and -9 to 1, like that, and close there, and we'll have union. So union there, it's going to be 5, and oh, it's open at 5. So open at 5, that's 5, and then at 9 it's going to be open like that. So this here is the set difference of a and x. So that's how we find that one. Okay, let us look at the next question. So the next question is x. So I still keep my x there since it's following up in the next one. X intersect z complement. So what's my z? I plot my z. My z is from -1 to 7. So z -1, at -1 it's closed, and then it goes all the way to 7, and it's open at 7. So this is what I have to be my z. So where do these two intersect? These two intersect here and there, like this part. So wow, but at -1 it's going to be open, since -1 is not in x, meaning it won't be in the intersection. So x intersect z is going to just be open at -1, then it goes all the way towards to 5, and it's closed at 5. So this is the intersection. Now, if this is the intersection, they're asking for the complement. The question is asking for x intersect z complement. So everything that is outside this interval here, but is in the universal set. And what will that be? So everything outside here is going to be, that means it's going to be closed so it's going to be closed at -1, going all the way to what? To -9, to be open there. Since it is open there, then at 5, it's going to be open at 5. Since 5 is in the intersection, it won't be in the complement of the intersection. So then going all the way to 9 there. So that means x intersect z complement is just going to be from -9, open there, to 1, close there, union. Then you have that then from there you're going to have it's going to be open at 5 and also open at 9. So this here is going to be x intersect z complement. Why are we seemingly getting the same answers? Anyway, we continue the next part. The next part is asking for set difference. So let me erase this here. Okay, so next part is just asking for, first of all, we have the set difference of x, of y and z, which is just y intersect x complement. So our x, as you've seen, we were plotted here, was running from, our x is running from 1 to 5. The complement then means it's closed at 1 going here. It's going to be open there. And then at 5, it is open going there. It is open. So this is x complement. Then y, if we were to plot y is -5. So let's say -5 is here to 3. So, and we say 3 is here. So plotting that, I'll have -5. It's closed here at -5, also closed at what? At 3. Then where do these two intersect? So they intersect here and there. This is where they intersect, these two parts. And look at the endpoints. The endpoints are both closed, so meaning it's going to be what? Closed. So that means that this here is just going to be -5, like this, -5, then it's going all the way to what? To 3, and it's closed. Now, that's just the first part of what they're asking for. Then they're saying intersect z, which means where is it common with what? With z now. So I'll plot z here. So plotting z is going from -1 to 7. So where we have -1 here, it's closed at -1, and it's going to 7, and it's open at 7. Then where now do they intersect? So let me just leave the set, this set, the first part. So let me erase this here. Okay, so you erase this here, erase. Okay, so now considering this, where we said -5, at -5 all the way to 3, and it's closed at 3. Now here, so this blue part, the blue part is for the set difference of y and x, whilst the red part is the set z. And then what is the intersection of the two? So it's going to be here and there. This is where they intersect. This is where they have the common elements. So that means y set difference intersect z is just going to be equal to, so there it's going to be closed. It's closed at -1 and going to what? All the way up to 3, and it's closed at 3. So this here is that part. Well, okay, we move on to the next question. And for the next question, we have this here. So we have a set A given like that, which is just a list, or it has numbers from 1 to 9. While list B here has numbers 1 to what? To 5. Well, when they are listed in interval notation, meaning they are real numbers, of course, when they're listed in interval notation, it means that it includes all the rational numbers and the irrational numbers that are there. So B and C are listed in interval notation, meaning these are real numbers. Whereas when you look at A is just a list of integers from what? From 1 to 9. So they're just integers from 1 to 9. Now they're asking us, the universal set is a set of real numbers. Set of all real numbers is the universal set in this case. If necessary, use the what? The number line and find. So saying if necessary. So if I look at A intersect B, so A intersect B. So B is from, so my set B is going, starting at 1, going to 5, but 5 is not part of the set. And then my A is just, of course, integers from 1 to 9. So this first part where it is saying A intersect B. So the only things that will intersect here are going to be the integers. So the integers are what will intersect, and the integers starting from 1 to what? To 4 in this case, since 5 is not in that set. So those integers are going to be 1, 2, 3, and 4, like this. So I put them there. Then the other part, so union, you look at the other part here. The other part is telling me I have A intersect C. So what is A intersect C? Again here, now for C, we see that there's 3 and 8. So 3 and 8 are not in the set. but every other number in between 3 and 8 are in the set. Every other real number in between 3 and 8 are in the set. So now intersecting it with the set A, which is just the set of integers from 1 to 9, we see that those that are common, that will start from what? 4 to what? To 7. Those are the integers that are common in both of them. So that is going to be 4, 5, 6, and 7, like that. Now, from here, these are the two. Then they're telling us union, bringing everything together. So in short, A intersect B, union A intersect C is just going to be, so union means the element is either in one of that set or the other one. It's either in that set or the other. So it means I have to bring all the elements together. So that is going to be from 1, 2, 3, 4, 4. I don't repeat since it said they're distinctive, 5, 6, and 7. So this here is the answer to that question. So I said if necessary. So in this case, it was not necessary for us to use the number line. Okay, so let's consider the next question. So the next question is asking us for the intersection of B and C, intersection of these two. So let me plot them. I'll use a number line for this one. So B, we have 1, and it is closed at 1 here, and it's going all the way to 5, like that, and it is open at what? At 5. So there, that's my B. And then my set C, 3, it is open here all the way to 8, and 8 like that, it is there. So this part here is where they are intersecting. Of course, not the endpoints, because it's open at the endpoint, it means they're not there. So they're not part of that set. So which means B intersect C is just going to be the set from 3 going to 5 and open on both sides. So this is what I get. Okay, next, I don't erase this. I don't erase it. I keep it for the next question, which is B union C. So union means I bring everything together. So everything from 1 here to 8, I bring it together. Though observe at 8 that 8 at 8 C there, the element 8 is not in C. So meaning even in the union, I will not include it. It has to be what? Open at that end. So the B union C is going to be at 1 here, it's going to be what? Closed at 1. Then it's going all the way up to 8, and it will be open at 8, since 8 is not in that what? In that set. Then they're asking now for the complement. So the set of real numbers being our universal set, it means everything that sits outside this here, everything that is outside this union of B and C, but is in the set of real numbers, means that that is my B union C complement. So that is going to go, since we are considering the set of real numbers, they go from negative infinity to infinity. So it means all points from negative infinity here, like that. Let me use a different color for this. Okay, from negative infinity there, like that, all the way towards to 1. So 1 is in the union, so it will not be in the complement, so it will be open here. Then union 8. So 8 is not in the union, meaning it will sit in the complement of the union. So it's going to be closed at 8 and all the way to positive what? Infinity, like that. And this here is my B union C complement. So this is how I get that. Okay, let us do the last question for this video. So the last question is we have B complement union C complement, like this, intersect A. So this here I can rewrite as B intersect C, then I put the complement outside there. This is by the De Morgan's laws. Then intersect what? Intersect A. So what is B intersect C complement? So I look at first my intersection, which I had found, of course, in the second part of the question. So the intersection here we had found it was going, that is 3, not 3, of course, open at 3, and then all the way up to 5, and it is open at what, at 5, like that. So this is B intersect C. So this is B intersect C. Now what is the complement? Everything that is outside here but is in the universal set. So that means everything there, our universal set in this case being a set of real numbers, like that. So let me plot this. So this is 3 and 5. So it is open here and open there. So this is my B intersect C. So it means the complement is going to be everything outside. So it will be closed here going this side and closed there going the other side. So this is my B intersect C complement. So my B intersect C complement is negative infinity to 3 closed here, there, union, then from 5 to positive infinity there. So this here is my B intersect C complement. Then they're telling me intersect this with the set A. So intersect this with the set A. So when I look at the set A is just a set of points. Set of points from 1 to 9. So if I was to write that, let me try listing these here. So I'll have, if 1 is here, so 1, 2, 3 there, then I have 4, then 5, 6, then 7, 8, let's extend, and it goes up to 9, like that. So, okay. Now, they're telling me where do these intersect. So, focus is on the, let me rub this blue one. So, the focus is on the green one. So, where do these intersect? So, these points, if I was to plot them, so I'm going to have there, one, there, 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 then I'll have another there, like that, like that, like that, and like that. So where do these intersect with the green ones? So they intersect, okay, so the intersection is going to be, okay, let me erase this here. So the intersection, so the final answer, let me write here, B complement union C complement intersect A. So where the red dots intersect the green line, that is going to be, so I have this part there, there, here. So there it does not intersect, but here it does, there, 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 and there. So the intersection then is 1, 2, 3, 4 is not in the intersection, but 5 is, 6, 7, 8, and 9, like that. So this here is in the intersection. And this is how you find these questions concerning real numbers on a real line, using the real line. And this is how you work out all this. Well, if you're new, remember to subscribe, and we see you in the next one.